Hello everyone, welcome to JFO Aviation Films. I am briefly today going over the electrical system for the Cessna 172. I'm using a G1000 system just to clarify all confusion. All of this information is straight out of POH Section 7, so you can reference that to follow along if you kind of like to listen and read to retain information. And you can go back to that section as well if you want to look stuff up. But I think it's helpful to have things audibly since I can listen to things while I'm making dinner or doing chores or whatever it is. So here is an overview of the electrical system in the 172. Some of this will be really good to know for pilots of all levels. Some of it you don't need to know until you're later on, and I'll do my best to differentiate that as we go along. But the first few things that we cover as we get started will be important for you to know, regardless of whether you're a student pilot, commercial pilot, CFI, whatever it is. All important to know. Little disclaimer, when you are preparing for a flight, do remember that every aircraft is different. Every aircraft might have different modifications that change a little bit some of the details of the things that we go over. So just do keep that in mind. If you have questions about your specific aircraft, do make sure that you cross-check your POH, make sure you're aware of any differences that exist, and remember to correct for that when you're doing your pre-flight planning. Some basic facts about the 172, again important for everyone to know. We have a 28-volt direct current electrical system. And our alternator, which is our main source of electrical current, or our main source of, like electrical energy, if you will, pulls 60 amps, 60. It's also a battery, which pulls 24 volts and just under 13 amps, about 12.75. And in the G1000, we also have a standby battery that supplies power to the system if the alternator and main batteries fail. The steam gauge 172s do not have a standby battery, but it is there in the G1000, so if you don't fly G1000, that's the difference there. The main ways that our instruments, the systems themselves, get electrical current is from electrical buses. There are a bunch of electrical buses on board the aircraft. The electrical bus, there are two electrical buses that will send currents to instruments and systems. It's an essential bus, which we will get to in a minute, but the essential bus is all of your basic information. So if you do have a complete electrical failure relying on that standby battery, that essential bus will get power no matter what. And then there's also a cross-feed bus. So those are also connected to primary buses that will support electrical equipment. And the primary buses get power whenever the master switch is on. So you throw that master switch on, primary buses are powered, and they'll send electrical signals to both electrical buses as well as the essential and cross-feed buses. There are also two avionics buses, avionics 1 and 2, that are powered by the avionics master switch. So every time you throw that switch on, do note in the 172, the avionics switch is a rocker that has two different sides. So you can toggle each bus independently. In normal operations, in actual flight, we always have both on at the same time, but if you need to isolate one or the other, if one's having a problem, you can shut it off by itself and keep the other avionics bus, which is a really handy feature to have. Some other aircraft, I think the Diamond DA-40 only has one switch that handles both, so you get all or nothing. So it's really good to be able to switch between the two as needed. Do note, little sidetrack, avionics switches are kept off whenever the airplane is being started. So whenever you're turning the master switch on or off or starting the engine, just to prevent transient voltage from moving through the system and potentially damaging the physical structure of the aircraft. Depending on your stage of training, you won't need to know what is on every single bus, but it's still good to know just to have a general idea. And the circuit breakers actually in the aircraft are lined up based on which bus things are on. So it's not kind of a one-to-one, as you'll see, but I think like the alt field circuit breaker is in here somewhere. I'm pretty sure that covers, or maybe ADC AHARS, that's a good example on avionics. I'm skipping ahead a little. ADC AHARS covers multiple things, so there's kind of a cross reference there. But when you look at the actual, back to the first slide there, but when you're looking at the actual panel of circuit breakers in the aircraft, they are loosely broken up based on the main bus that powers each item, which is really helpful. So again, if you have kind of some electrical issues and you suspect a problem with a particular bus, you can kind of cross-check some of the things on the circuit breaker panel against what symptoms you have of a failure and determine what the root cause of the issue is. But we'll skim quickly through what is on each bus here. First with the two electrical buses, 1 and 2. Electrical bus 1 has your auxiliary fuel pump, beacon light, landing light, overhead lights. Those are in the cockpit. So when you're flying at night and you want the cockpit light, as well as the 12-volt cabin power if you're plugging anything into the aircraft to charge, for example, as well as flaps and avionics bus 1. So whenever electrical bus 1 is powered, you also get the avionics number 1. Electrical bus 2 will have panel lights, wing strobe lights, taxi lights, as well as the control wheel map lights and nav light, which is on the same circuit breaker, and the pitot heat, and avionics bus 2. Do note, I should have mentioned this, everything inside the parentheses is a circuit breaker that controls that piece of equipment. So when you look at like nav and control wheel map light, for example, you control both of those things on electrical bus 2 because nav light 2 is on that circuit breaker. So if you trip nav light 2, you can lose both the nav light and the control wheel map. Good thing to note here is that you have some sort of anti-collision light on each bus. So you have the beacon light on electrical bus 1 and the strobe lights on bus 2. The strobes are the required anti-collision lights for the 172 if you go into the kinds of equipment list. So you can actually kind of lose electrical bus 1 and still be legal in terms of your electrical lights, or in terms of your anti-collision lights. But as always, good to have both and good to keep tabs on what's going on. Quick look at the avionics buses. Avionics bus 1 will power your primary flight display. That's the screen on the left. It will have your PFD cooling fans, so not the it does have the PFD, so the screen itself, I guess, and the cooling fans. Have your ADC and your AHARS, so all of the flight instrument for these PFD, all of the computers that power those flight instruments are on avionics 1. There's also nav 1, the top VOR radio, as well as the engine airframe unit. Again, both of those are in the same circuit breaker, so you chip that, you lose both. And then if installed for the rest of these 3 flight information system, as well as your ADF, your DME. So a lot of newer aircraft won't have those, so you won't need to worry about that. But if you do have those on your plane, those are both on avionics 1. Avionics 2, multifunction display and MFD fan, MFD circuit breaker. So there's your transponder, navigation number 2, VHF COM2, so your audio panel, and your autopilot if installed. The fact that VHF COM1 is not on Avionics Bus 1 is not a mistake. That's coming later. But good to know here, if you lose one of your two avionics buses, you do not lose both of your screens. So if you lose, for example, avionics 1, you lose that PFD, you can still use reversionary mode onto the MFD to get whatever flight information is still available after you also lose the ADC and the AHRS. So, kind of your navigation information, for example. So you will have reversionary mode still available, even if you lose one of the avionics buses, as long as the other one is still available. Essential bus, this will have all of the basic things that you need. So the primary flight display is also on the essential bus, air data computer also on the essential bus, ADC AHRS, that whole circuit breaker, NAV1, engine airframe unit and voltmeter, as well as COM1, standby indicator lights, and to and from the standby battery. So pretty much everything else will just get in from, send stuff from the bus, send electricity from the bus to the equipment, but standby battery system will go to and from the essential bus. And again, you will notice that there are a few things on the essential bus that are kind of copycats from Avionics 1. That is primarily there for redundancy. So if you lose Avionics 1, you will still have the basic, ADC AHRS, you'll still have the flight instruments and all that, so that losing the bus does not kind of doom you to losing all that information. So all of that redundancy plus the MFD on Avionics 2 it's a good backup. Then the crossfeed bus will have your alternator master switch, as well as a series of warnings. So the warn circuit breaker will has things like your stall warning, your autopilot warning, ELT warning, and then it also has some of the monitoring equipment that you would want otherwise. So main bus voltmeter, hour meter, and then standby battery, starter relay to start the engine, and the main bus sense, all on the same warn circuit breaker. So again, if you lose that, it's going to have a big impact on your flight, but definitely plane will still be flyable. Take a bit of a deeper dive into the master switch, and again, you don't really need to kind of know every single last word on here necessarily, but it is important to note that you can isolate the alternator and the battery, so you can turn on one without the other. The battery can be selected separately, the alternator should not be. So as long as the alternator is on, you can, or I guess you must have the battery on per the POH. But the good thing about being able to isolate is that if you have an issue with that alternator, if it is, you have an overvoltage situation, for example, you can deactivate and isolate the alternator to let it cool down and reset before testing it again, and you still have electrical equipment from the battery. In normal operation, so about 99.9% of the time, both of those switches are going to be on. So it's really not something you need to think about much anyway. But regardless, do be aware that you can select those two separately. If the main battery does fail, as long as you have that standby battery switch armed, and we'll get to the standby battery in a minute, the standby battery can just take over the electrical load. So always a great idea to have that standby battery on, not only for that reason, but for also one or two others that we will again get to in just a moment. Alright, that standby battery has a 3-position switch, kind of on the top left side of the instrument panel. So normally in that neutral position, it is set to off. Before starting up, we always test that battery by manually holding down the little switch where that kind of green light pops up. And as long as that green light is activated about 10 to 20 seconds, we have an indication that the standby battery is functioning normally. And then obviously we throw that switch all the way to the top to arm it, and that will turn on the standby battery switch and power that essential bus. Having the standby battery armed during flight has two main benefits. One of them is that it allows the electrical system to regulate and filter bus voltage during the start cycle. So it kind of protects that essential bus in a sense, and protects the equipment on it to make sure that if there is any harmful voltage during startup, kind of moving through that electrical system, that voltage will not impact or damage the equipment on the essential bus. Will make sure that we always have the same basic essential equipment that we need for flight. The other benefit is that it will help to power the electrical system in the event of an alternator and a battery failure. So having the standby switch on during flight, during just normal operations, is going to make sure that that battery is charged fully, so that in the event of a total electrical failure, it can take over seamlessly to keep powering that essential bus. The standby battery will power the essential bus for up to 30 minutes. So obviously that time will change a little bit based on how much equipment is turned on and how much voltage is being used, the health of the battery itself. But we get up to 30 minutes of additional electrical power in the case that our other systems fail. Switch, just like the master battery switch, is a 2-pole rocker type switch, which essentially means that you can isolate either Avionics 1 or Avionics 2, either of those buses. So you can turn each of them on and off independently if you so desire. Again, usually when they are in flight, both are on at the same time, so both Avionics buses receive power. But you can isolate them so that if one bus, for example, has an issue and you want to turn it off, prevent damage to further parts of the system, or if there is electrical, kind of alternator failure, for example, you want to save some energy, you can turn off one of the Avionics buses to isolate it or to preserve battery power, whatever it is. And we do test independently on the ground, so as you're going through that pre-flight check, you'll know that the checklist calls to check each bus independently to make sure that the proper equipment comes on when you turn the bus on, that the associated Avionics fan activates, all that fun stuff. Friendly reminder that Avionics switch should be off when the master switch is turned on or off when you're starting the engine or when you're applying an external power source. Again, that's to prevent transient voltage from jumping from the Avionics to the other electrical equipment or vice versa, in order to prevent doing damage to the system. Quick look at the indications for the electrical system. The voltage indication is provided on the engine indicating bar on the, I guess it's on the MFD in normal operations. You'll have volts indicating for both the main bus and the essential bus at the bottom of the EIS bar. Normal bus voltage is about 28, so when you're starting up, you should see 28 volts plus or minus a couple tenths. If the voltage drops below 24.5, that is a pretty solid indication that your alternator has failed and that you're running on the bus, or on the battery alone, So at that point, you're really going to start seeing the battery start to drain out, the main battery at least. There's also an annunciator above 32 to indicate that the alternator is overproducing energy, which will cause it to heat up and will have issues of its own. Any indicated voltage kind of between 24.5 and 28 may occur during low engine RPM, so you might have seen that annunciator when you're kind of rolling off the runway at idle power on the ground, and you kind of hear that little chime. That's normal. Solution to it is pretty simple, just to bump power back up to about 1,000 RPM. You will remember bus voltage is measured at the Warn circuit breaker on the crossfeed bus. So if you lose that crossfeed bus, then you're going to lose that indication. See, I have Essential Bus Vintage instead of Voltage written up there. That'll be on the NAV1 engine circuit breaker on the Essential Bus. Ammeters provide indications to show how well the alternator is charging your batteries, which is going to give you a good indication on the health of that alternator. It's provided for the main bus with the M and the standby, or I guess the main and standby batteries, and it's again at the bottom of the EIS bar on that MFD right below the voltmeter. Normal indication, if that ammeter is indicating 0, the alternator is providing the exact amount of energy that the system needs to continue to function. So if you have anything more than 0, so if the indicator is positive, then you know that the system is charging. So most likely, for example, after you start up, you kind of used some of that battery power to activate the starter motor, starter relay to start the engine. You provide this spark to the spark plugs. The alternator might kind of charge the battery up a little to cover that difference. And in the inverse, if you are demanding more power from the system than the alternator itself provides, you'll see a little bit of a negative indication to indicate that some extra power is being pulled from the battery to provide enough energy to the system. Any battery current above negative 1.5 is shown in white, and if you have batteries below that, or I guess amps below that, below negative 1.5, you're going to start seeing the yellow block as well as an annunciator popping up. The standby battery annunciator comes on when discharge rates are greater than 0.5 amps, so more than negative 0.5, for more than 10 seconds. So when you look at, for example, the standby battery, or the PFD, when you turn on that standby battery to start up the aircraft, you'll see after everything turns on that you have that standby battery annunciator, because the battery is discharging enough for long enough that that annunciator is going to activate. And then in flight, obviously, if the alternator fails, battery fails, you're going to see that standby battery annunciator to tell you that you are relying on the standby battery and you know that you really need to land imminently. Low voltage annunciation already covered, but that comes when the bus voltage measured in the power distribution module is 24.5 volts. So again, it's an indication that the alternator is not supplying electrical power required by the aircraft, and that instead all of that power is being provided by the battery. You might get that indication if I know that this third paragraph kind of says over voltage. That might come on if the alternator is shut down in an over voltage situation. So the alternator control unit can automatically do that. So you will be able to use that low voltage annunciator to kind of mark the progress of your troubleshooting and of the system, and as a benchmark for when to try to turn the alternator back on again. If your low voltage annunciator does come on, do check the alternator circuit breaker, as again the alternator control unit may have popped it automatically to deactivate the alternator if it's overheating, producing too much power. As is a general rule with the circuit breakers, you get one chance to reset it, to try to reset the system. If it keeps popping over and over and over again, the circuit keeps opening, don't keep trying to reset it. That's going to indicate a larger problem to you that you need to address. But if the breaker pops for whatever reason, you get that low voltage renunciation, just make sure that, see whether that circuit breaker is popped and determine whether to reset it. High volts, the annunciator comes on above 32 volts, and if that happens, immediately your first action should be to turn the alternator side of the master switch off. The alternator control unit might automatically open the alternator circuit breaker, so the alternator current will be removed from the system and stop output, which is going to give the alternator time to cool down after all that extra energy is going to kind of heat it up a little extra. If you keep getting indications every time you try to reset the alternator, again, make sure that alternator master switch is off, and check section 3 for emergency procedures for your checklist for what to do next. And then last section, just a little overview of your circuit breakers. Any circuit breaker on the essential bus on either of the avionics buses can be popped by the pilot. So if there's a problem with the system, or you want to deactivate certain equipment in the event of a failure, of either an equipment failure or a electrical failure in midair, you can deactivate circuit breakers in order to meet the situation. Electrical bus 1 and 2, as well as the cross-feed bus, cannot be opened or disengaged automatically by the pilot, so nothing you can do about those. Do note that popping the circuit breaker is not something you can just casually do, right? Unless you're a mechanic, the only time you're allowed to pop those is if you are meeting an emergency in flight. So if you have an electrical failure, or if you're troubleshooting a problem in flight, whatever it is, that's not something that you can just casually pop on the ground unless you're a mechanic. So do be mindful of that. It's an FAA regulation, if you're curious. If you want to try to turn the equipment back on, if something kind of popped on its own and you want to try to reset it, you could just push that circuit breaker back in to close the circuit again. But again, if the circuit breaker pops a second time, or if the equipment keeps overheating or whatever it is, just keep that equipment turned off, keep it shut off, and go from there. The last thing you want to do is have things overheating, starting fires. It's much better to just kind of keep everything under control and land with limited equipment versus cause an emergency that's worse than it already is. The G1000 itself, so if you look at actual the G1000 equipment instead of the aircraft equipment, all of those fuses are not field replaceable. So if you need to get components in the G1000 itself replaced, you actually have to go to a Garmin dealer to do that, or I guess an improved service station. So just be mindful of what it means to see a circuit breaker pop, how to respond to the situation, and when to respond. Thanks very much for watching. I hope you have found this video informative and helpful. I look forward to seeing you again in the next video, so make sure to subscribe so you know when the next one comes out. In the meantime, safe flying, safe studying, and best of luck in your next endeavor.